at times. In a minute. Okay, so number 18. This is like foiling, but it's not foiling because there's more to it than foiling has. You need to make sure you multiply every term by every other term in the other binomial, trinomial. So I'm going to start with 2c, and I'm going to multiply 2c by everything. Okay, so what is 2c times c squared? 2c cubed, yeah, third power. So you're adding your exponents on that. Then it's 2c times 3c is what? Oh, you're right, negative. It's a negative 3. Minus 6, and that's c squared. Okay, then it's 2c times a negative 11 is a negative 22c. Okay, so I'm just taking that first term of the binomial and multiplying it by everything. Okay, what's your next move? The 1. Take that 1 and distribute it to everything. So 1 times c squared is a positive c squared. 1 times a negative 3c is a negative 3c. And 1 times a negative 11 is a negative 11. Okay, so you take all the blues, do it all. Then you take the pink, do it times everything. And now you just have to simplify. So combine like terms. 2c cubed, is there another c cubed anywhere? Nope, so that's done. 2c cubed. Then you have a negative 6c squared plus c squared. What does that become? A negative 5c squared. So negative 6 plus 1. Okay. Then you have a negative 22c minus 3c. That's a negative 25c. And then your last thing is that negative 11 that has nothing to combine it with. So that would be your simplified answer. Questions on that? Okay. Which one? You said 17? Was that Mike? Okay. So 17 is foiling with a coefficient to the x, which is maybe a little bit different than the most common. FOIL says do the first. What do you get when you multiply the firsts? 6x squared. Okay, then you do the outside. That's a negative, so is it 2x and a negative 9 is a negative 18x. Then you do the inside, which is a negative 21x. What do you get for the last? Positive 63, right? A negative times a negative is a positive. So really all you have to combine are your x's here. You get 6x squared minus 39x plus 63. Okay. 19 is just like number 18 that we just did, so I want you to try that one on your own eventually. Don't do it right now. I'd rather you stay with me right now. What's different about 20? You just distribute. It's not a binomial, it's a monomial times a trinomial. So that 2z is going to get multiplied by everything. What's 2z times z squared? 2z cubed. And then it's minus 10z squared, 2z times 5z, and then it's plus 12z. So that would be your simplified answer. Okay. Okay. Yes. Go quickly. Leave your phone. 21 to 26 is all factoring. Okay. I'm actually going to, I'll do 21, 23, 25 with you. I'm going to have you do 24, 20, 22, 24, 26 on your own, okay? Because they're basically mirrored problems. So look at number 21. How do you factor that? Is there a GCF? No GCF. Okay, so without a GCF, you jump right into star method. This is a really great thing to put on your note card. It's also on the back of your final exam. it's the star that looks like this, where this is A times C, this is A, this is B. If I were you, I would be even more specific and say, what can I multiply that I can add? Just to help you remember which one goes with which. Okay, so in this situation, what's gonna go up top? 30. And then on bottom, so this is your A term, your B term, your C term. So on bottom is a negative 13. Your A term is 1. What can you multiply? Okay, now here's the thing. You're multiplying to get a positive, but you're adding to get negative. What's going to be true about those two numbers? They're both going to be negative. If you multiply to get a positive, but add to get a negative, that means both numbers have to be negative. What two numbers? 10 and 3. So this becomes x minus 10 and x minus 3. Now, it's going to be tempting right now to keep going. But what do the instructions tell you to do? Factor it, not solve, okay? It's not saying this equals anything right now. It's just saying put it into factored form. This is your factored form. So you're done at that point, okay? Look at 23. Is there a GCF? No GCF. Okay, if there's no GCF, what's your next move? Factor it by, look for, is it a difference of squares? Can I do star method? In this case, it's not a difference of squares. We're going to do star. What goes up top? Not negative 2. Negative 24. The A value times the C value. So negative 24 and a 5 down here. Your A value right now is a 12. That's a pretty big A value. What can you multiply to get a negative 24 that you can add to get 5? What? A positive 8, a negative 3. What's your next move? Simplify. You got to reduce those fractions. Khalees.
Wait, how do they get to negative 24 and 5?
So A times C, right? This is A times C. This is B. So here's your A, here's your B, here's your C. Okay? So simplify this. 12 over 8 would be, divide by 4, rather, would be 3 over 2. Over here, you can divide by 3, so that's 4 over negative 1. So you're doing 3 over 2 and 4 over negative 1 and turning those into binomials. What binomials would you get? 3x, right? The top number goes with your x. 3x plus 2. So what's the other one? 4x minus 1. Okay, so this is your factored form, and you're just done at that point. You don't have to solve for anything. You're just factoring it. Okay. Questions on that? Yeah. So A times C is what goes up top. So I did 12 times negative 2 to get a negative 24. Is that what you asked? We did. A times C is 30. It's just your A value is 1, so it doesn't change it. It's always A times C. It's just when your A value is a 1, it looks like it's just C. It's never just C. It's always A times C, but A was 1. That. Because that's your A value. The A value always goes right here. So it'll always be in this format. It'll always be the A's here, A times C here, and B right here. Okay? Put that on your note card, that format. And then you just have to drop in numbers where they go. Okay, 25. What do you have to do here? First move. Should be the first move you always look for. GCF. Is there a GCF? Yes, you can take out a 2. So if I take out 2, I'm left with y squared minus 49. What do we call this? What? It is a binomial. That's a difference of squares. Maybe on your note card somewhere, for sure on your note card somewhere, maybe you want to write, if you have something that is like an a squared minus a b squared, okay, whatever a and b stand for, it's going to become a plus b, a minus b, right? You're going to square root your a and b and turn it into this format. Okay, or maybe you want to just write it in with numbers in it. Maybe you want to put this exact example on there. I don't know how you want to represent that to make the most sense to you, but a difference of squares will always be square root them both, and one is plus and one is minus. Okay, so you have this 2 out in front, but then you get these two binomials. The square root of y squared is y. The square root of 49 is 7. So this is plus, this is minus, and that's your answer. How can you check your answer? You can't really plug it in. There's nothing to plug in. You can FOIL it, right? If you FOIL this and it gets back to where you started, then you're good to go. Okay, but definitely put something difference of squares on your note card. Okay. Okay, shall we set up the chart? I think we shall. I would put this on your note card too. There's not a ton of this on the final, but it is on there. And inevitably, it's gonna get mixed up. This isn't really big enough. Okay, so we're gonna say, did we do degree first? We usually did degree first. The degree and the name based on degree, and then the number of terms, and the name based on number of terms. Yeah, I would put this on your note card, okay? If the degree is I'm going to give you an example out in front. Let's do this. The number 15. What's the degree of that? It's 0, okay? If the degree is 0, do you remember what we call that? It's a constant. Yeah, that's a constant. How many terms is that? That's one term. Okay, so this is a constant. It is one term, which we call a monomial. Okay, let's do another one. Let's say we have 3x plus 1. What's the degree of that? That's a degree of 1, right? X to the first, so a degree of 1. What do you call something with a degree of 1? If you graphed this, what does that look like? Linear. This is linear. Okay, how many terms is it? It's 2 terms, which we call a binomial. Okay, what if I have x squared minus 2x plus 4? What's the degree? A degree of 2. It's your highest exponent, okay? What do you call something with a degree of 2? It's tricky. No, that's 4, but you're on the right track. Quadratic. Okay, so that's a quadratic. There are 3 terms, which is a trinomial. Okay, let's say you have x cubed plus 6. That's a degree of 3. What do you call that? Cubic. And what if it's x to the 4th plus 6x plus 1? That's a degree of 4, which we call quartic. We're going to be done right there. So the 3 names that we did were monomial, binomial, trinomial. Anything past that is just a polynomial. And the main ones we did for degree were 0, 1, 2, 3, and 4. Did we do 5 in here, or is that just algebra 2? Did we do kinetic?
No.
No, okay. Something to look forward to in algebra 2. Okay, so I'll let you try 27 and 28 on your own. Here are 3 formulas that you absolutely want to put on your note card. Are you done with this? Can I move on? Axis of symmetry. For what? This? Nothing. I didn't do those because we already did them over here. Okay. So 3 formulas. Do you remember the axis of symmetry formula? X equals negative B over 2A, okay? You absolutely want that on your formula sheet, right? Axis of symmetry, and then X equals negative B over 2A. Yeah, both sides, yeah. What's the quadratic formula? Do you sing the song when you say that? Pop goes the weasel. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's great, huh? No, you're going to write it on your note card so you don't have to remember it.
Isn't it on this?
It's on the review.
Do we keep it?
No. No. You could use the note card. Yes.
Isn't there like a, and then, so there's a tiny one, and then it equals something, which one was that?
A tiny one?
Like, it was,
I don't know.
it was like an A or a tiny one, or like a 1 and a tiny A.
Oh, a tiny number 1.
Yeah.
Oh, gotcha. We'll get there. That is, oh no, did we do that already? Was it what?
Oh, yeah, that.
This stuff. Is this what you're talking about?
Yeah.
Yeah. That was the stuff that we did, geometric sequences and arithmetic sequences. Yeah. I'm trying to think if I don't think there's ever a time where you have to write that formula. It'll be there for you and you have to plug a number into it. Okay. Last formula. What's the discriminant? It's right there. Yep. The discriminant is b squared minus 4ac. Do you remember what the discriminant tells you?
So like
How many solutions? So on your formula sheet, say if D is positive, 0, or negative. Okay? If your discriminant is positive, how many solutions do you get? 2 solutions. Put it on your note card. If your discriminant is 0, how many solutions do you get? 1 solution, because the square root of 0 is just 0. So that's 1 solution. If your discriminant is negative, no solution. Put it on your note card. Moving right along. We are gonna do one of each of these together. And I'm gonna leave the other ones for you to do for homework, okay? Or time to work at the end of class if we have more time. So these first ones, it says solve the quadratic equation using the quadratic formula. What's the quadratic formula? It's on your note card, right? This should be easy. Okay, when can you use the quadratic formula? What does the format of the problem need to be? Something equals 0. It has to be equal to 0 before you can plug it into the quadratic formula. So look at this first one, letter A. 2x squared minus 4x, you would have to subtract the 6, and you get this. What is your A value? A is 2. What's your B value? A negative 4. And what's your C value? A negative 6. Okay, so if we're taking those numbers and we're dropping them into the quadratic formula, we say x equals, what is a negative B? A positive 4. Plus or minus the square root. Here's the most important part of the whole problem. Parentheses around your B, and then you square it. Please don't forget the parentheses, okay? B squared minus 4 times A times C, and all of that over 2 times A. Do you remember what I always said to do as your next step? The stuff under the radical. Don't plug in the square root right now. Just plug in what's under that radical symbol. So don't go square root of all of that. Just plug in parentheses negative 4 squared minus 4 times 2 times negative 6, and you get 64. So this is 4 plus or minus the square root of 64 over 4. What's the square root of 64? It's 8. So this is 4 plus or minus 8 divided by 4. And I think it's tempting to leave that as your answer, but there's no math here that you can't complete, okay? So turn this into two separate things. 4 plus 8 divided by 4 and 4 minus 8 divided by 4. If you simplify that, that's 12 divided by 4. Yes. Because we had to move it over. You want it to equal 0. So we had to go minus 6 to set it equal to 0. No. You always have to move everything away from the right side of the equation so it equals 0. So in doing that, our C became a negative 6, but C doesn't have to be a negative. Then you would plug it in as a positive. Would it still be what? If it was a positive? Yeah, I mean, you plug in whatever the value of C is. So if C is a positive 2, plug in a 2. If C is a negative 6, plug in a negative 6. Right? Yeah. This? Right, it's the opposite of B. B right now is negative. So the opposite of a negative 4 is a positive 4. Opposite of B. Yep. Yeah. Okay, 4 minus 8 is a negative 4 over 4. So your other answer here is a negative 1. So you get, on letter A, two answers, 3 and negative 1. Okay? How do you solve by square roots? You divide. Maybe you want to write on your note card when you solve by square roots, you want to isolate your x squared. okay? That means get x squared by itself. This one is not set it equal to 0. In quadratic formula, you need it to equal 0. This one doesn't need to equal 0. You're going to divide by 2, and you get x squared equals 36, and then you're going to take the square root. What do you get? Plus or minus. Good job. 2 answers always on quadratics, right? It's a second degree. It's x squared something. 2 answers, okay? Plus or minus. Okay. This third one is solve by factoring. So this is not just factor it. Now this is solve it once you have factored it. What do you do first? Ask yourself the question, is there a GCF? Is there a GCF? No, because this is a -1, this is a 6, this is a -2. Nothing you can factor out of that. So no GCF. Is it a difference of squares? Nope, there's an x term, right? So it's not a difference of squares. So then what's your next move? Star. You're going to do star method. What goes up top? Thank you, Alan. -12. 6 times a -2 is a -12. What goes on bottom? A -1. That's your B value. What's your A value right now? What goes here? 6. So a 6 there and a 6 there. Now you ask yourself the question, what can I multiply to get -12 that I can add to get -1? A -4, a +3. So if you simplify that, 6 over -4 is 3 over -2. So you're going to use that one. 6 over 3 is 2 over 1. Don't call it 2. You leave it as a fraction, 2 over 1. Because then we're going to turn it into the binomial. So this is going to be 3x minus 2 for the first one. Remember, this top number goes with the x. So 3x minus 2. This one is going to be 2x plus 1. And that equals 0. How do you solve for x? Don't distribute. If we need this whole thing to equal 0, then either this needs to equal 0 or this needs to equal 0. So you set them both equal to 0 and you solve for x. 3x minus 2 equals 0. 2x plus 1 equals 0. So we would add 2 and divide by 3. So x is 2/3. Okay, on the other one, take away 1 and divide by 2. So x is a -1/2. 2 answers. Whenever you solve a quadratic, anything that has an x squared as its highest degree, that's when you should be getting 2 answers. Yeah.
I'm looking ahead. Is there not going to be any graphing?
I mean, we graphed
Other than
up here.
is that the only thing you graphing?
Do you want more than that? Yeah. I'm gonna let you do that when we have some downtime in a minute. If you want me to help you individually, I will. But I want you guys to try them now that I've done one with you. I'd rather you have practiced at it rather than me talk you through it right now. Okay, 33 through 35. There's a few questions like this where you should be able to tell me, oh, that's linear, or that's quadratic, or that's exponential. How do you know? Yeah, your exponent situation, the power, okay? So, for instance, this is what type of equation? It's a degree of what? 2. A degree of 2 is a quadratic. So this one is B. Okay. What's the degree in this one? It's a degree of 1. It's to the first power. What do you get with something to the first power? It's linear. So that's A. This one is exponential. Okay. How do you know something is exponential? when your exponent is a variable. Okay, when your exponent is a variable, then that's an exponential equation. Do you remember what exponentials look like? Those are the ones that look like this or like this, right? That's an exponential equation, whereas linear would be like this, and quadratic is the U shape, okay? So this is quadratic, this is linear, this is exponential.
And you know it's exponential when.
That's what these were. Exponential is when your exponent is a variable. Sorry, I should have drawn my pictures down here. That's what this is. Do you want better pictures? Do you want a better, here. If it is linear, it's a straight line. So your graph would look something like this. If it is a quadratic, then your graph is going to be a U-shaped curve. So something like that. If it is exponential, then your graph will be that curve that never touches the axis or never touches one of the axes. Okay, any questions on that? Yes.
Can graph be both quadratic and exponential, or it can only be one?
It would only be one. Yep. Quadratic will always be x to the second power. Exponential will always be something to the x power. Okay, let's talk transformations. This should feel a little bit fresh because it wasn't that long that we did transformational stuff. When it's in vertex form, remember this is vertex form, where it's x minus h, and then this is k. Where do you shift inside? That -4 means we're going to go 4 to the right. It's always opposite of what you would expect, okay? So inside is left and right. This is going to be 4 to the right because it's -4. Okay, if it's a +6 outside of the parentheses, where are you going? This is up and down because it's positive. You're going up 6. And then what does this number do? The 1/3. What? Compress or stretch. Okay. How do you know which is which? Maybe you want to write this on your thing. Compress versus stretch. Stretch is going to be numbers that are, their absolute value is greater than 1. So things that would stretch would be like a -2 or a +3. Okay, it's going to stretch it. It's going to, what's the other word we use for stretch? Do you remember? What? Narrow. Stretch is narrow. Compress is widen. Okay, so compress is a fraction between 0 and 1 as an absolute value. So that would be like a -1/2 or 1/3. Okay, that would be something that will widen, compress. So in this one, you have 1/3. So this one would widen or compress. Okay, you can write either word. I wrote either word on, I think there's a multiple choice question that asks you what it would do. I wrote both words on there because I used both all the time. Questions on that? Okay. What does a negative do? Flip it. Make it upside down. Okay, so this one would flip. It would also stretch or narrow. And then where would it move for that -4? Down 4. Okay. How we doing? Pretty good? I'm gonna give you vertex form over here. Maybe this is helpful on your note card. Remember, vertex form is y equals a times x minus h squared plus k. So maybe you wanna write, like if negative, then it flips. And then this stuff applies as well to that a stretch versus a compress. This is what gets you your vertex. So this is gonna move left or right, but opposite of what you would expect. And then this one's gonna move up or down, but the same as it looks like it would. So plus is gonna move up, minus is gonna move down. So this maybe is just helpful to lay out on there for you.